Welcome once again to my channel. We want to see how to solve this problem we have on complex number. Express the principal argument of z raised to power 4 equals to this in polar form. Now, for us to solve this in polar form, for us to express this in polar form, we have to remember a theorem called De Moivre's theorem. This theorem states that if you want to express any complex number to polar form, what you do is you say r raised to power of n bracket cos n bracket cos n bracket theta plus 2 pi k plus I sin n bracket theta plus 2 pi k. So this is what the theorem simply states, where r is called the modulus of the complex number. We say r, the modulus, equals to square root of x squared plus y squared. This formula was derived by saying that complex number is equal to x plus yi. Remember, it is called complex number because it has real number part, which is denoted with x, and imaginary number part, which is this yi. Now, it's also very important to know that this theta p I wrote here, we'll be calling it our principal argument. Okay? Now, k is called the value of numbers ranging from 0, 1, 2, 3 to as small as possible. So the implication is that if you say k is equal to 0 here, it means you are getting the principal argument in polar form. You are getting the principal argument in polar form. That is, the principal argument is called the first argument. I repeat, the principal argument is called the first argument you are to get in a complex number when expressed in polar form. But when you say k is equal to 1, you can see it's the second number. We say it is the second argument. When you carry it and put it here, what you'll be getting will be the second argument in polar form. K equal to 2, the third argument in polar form, and so on and so forth. Okay, let's solve the question. We say z will now be equal to, if this is this, z raised to power 4 equals to minus 8 bracket I minus root 3. In this number, this is the imaginary part and this is the real part. The real part is a part that do not have I. In complex number, I simply means square root of minus 1. Please, that means you can't get the answer to it. If you press square root of minus 1 in calculator, it will be giving you math error, syntax error, and so on and so forth. So this is the real number part and this is the imaginary part. So what we do here is that we now expand. We say z will be equals to minus 8 bracket I minus root 3 all raised to the power of 1 over 4. Whenever a whole number is crossing equality sign and that whole number was as a power in the other side, when it's crossing the equality sign, it will change to fraction. That is, if you have something like this equals to 2, and this power of 3 is to go to the other side, you say z equal to 2 raised power of 1 over 3. It is a rule in mathematics. Okay, when you have it this way, we now say that z will be equals to minus this times this will be giving me minus 8i, minus this times this will be giving me plus 8 root 3, all raised to the power of 1 over 4. Okay, now I will call this my real part, that is my x, because I said when you have a complex number this way, this is real part and this is imaginary part. So you call this your x and call this your what? Y. Now what you now say, for us to be able to package it this way, we have to get our r. R is equal to square root of x plus y. That will be equal to r is equal to square root of x squared, please, plus y squared. We call the r the modulus of a complex number. We call it the modulus of a complex number. So what we'll be having is square root of my x is 8 root 3 squared plus my y is equal to minus 8 all squared. So look at what it will give me. 8 root 3 squared means 8 squared 64 times root 3 squared will be giving you 3. I repeat, 8 root 3 all squared means 8 squared times root 3 squared. 8 squared will be giving you 8 times 8, 64. Root 3 squared will be giving you 3. 3 times 4, 12, carry 1. 3 times 6, 18, plus 1, 192. So we'll be having 192 here. Plus, minus 8 squared will be giving you 64. So 192 plus 64 will be giving me 652. So 256. Square root of 256. And that is what? 16. I will say I've gotten my modulus. I've gotten my modulus. I will also now try to get my principal argument. I've gotten R. To get my principal argument, I will draw this. This is the first quadrant. That is, when it is in the first quadrant, that is here is plus and here is plus, you say that your principal argument will be equal to rev theta, where rev theta is equal to tan inverse of modulus of y over x. But if it is here is minus and here is minus. If it falls here, that is this one, that you say PA equals to 180 minus rev theta. That is the second quadrant. This is first, second. Now, if it falls here, you say that PA is equals to rev theta minus 180. And when it falls here, say that PA is equal to minus rev theta. Now, with this simple information, what we do is that we bring out what is written inside, and that is minus 8i plus 8 root 3. We call this our x, it is positive, and we call this our y, it's negative. It means here is negative and s is positive. Look at where it belongs. Now, we now say that our rev theta will be equal to tan inverse of, what is my y? Minus 8 all over, what is my x? 8 root 3. Because you have modulus, it means that forget about minus, turn it to plus. This cancel this will give you 1. So we'll be having it to be tan inverse of 1 over root 3. Tan inverse of 1 over root 3 is equals to 30, because tan 30 is 1 over root 3. Just press your calculator. Tan 30 will give you 1 over root 3. Then tan inverse of 1 over root 3 will give you 30. Have it to be 30 degrees. That means ref theta is equal to 30 degrees. Therefore, PA will be equal to minus 30 degrees. Minus ref theta. We have gotten our principal argument, which we denoted as PA. Now, since it is in degree, you can also convert it to radian. You can convert it to radian. You will now say that now that 180 degree is equal to pi radian. Then 30 degree minus 30 degree will be equal to cross multiply minus 30 pi all over 180. This here 1, this here 6 equals to minus pi over 6. So that means this or minus pi over 6. So let's clean everything since we have gotten our PA. I will write it on the top here. We say we got our principal argument to be equal to minus 30 or minus pi over 6 radian. Then we also got our R, which is the modulus, to be equal to what? 16. Remember, our PA means principal argument. So we have noted the main points we needed in this formula. I will now clean. Okay. So what we now do is that we package. We say it implies, what is our R? We say our R is 16. What is our N? Our N is power of what? Power of 1 over 4. This is our N, the power. We now say 1 over 4 bracket cos. What is my N? 1 over 4. 1 over 4. So let me write, what is my theta P? A radian is minus pi over what? 6. So now say plus 2 pi k. Then times 1 over 4. That is your N, 1 over 4. And 1 over 4 times this will give you the whole thing over 4. We'll now say plus I sine 1 over 4, which is the power N. Remember, our N is 1 over 4. That is the power here. Remember, you must make the power you have in Z to go the other side so that you make Z subject of formula. It's very important. So bracket minus pi over 6 plus 2 pi k. So when you have it to this point, principal argument of a complex number is gotten when k equals to 0. This is because k ranges from 0, 1, 2, 3, and so on and so forth. So when k is 0, we are getting the first argument called principal argument. So first argument is called principal argument. But when k is 1, what you are getting is called second argument. When k is 2, what you are getting is third argument. So the question says find the principal argument. So what we do is say when k is 0, that is the principal argument. 0 times this 0 times this 0, we have this. Now 16 raised to power 1 over 4 means 2 raised to power 4 is 16 raised to power 1 over 4. That will be giving us 2. Oh, so we now write 2 bracket cos 0 times this 0 times this 0. So we will now have 1 times this is minus pi over 6 divided by 4 minus pi over 6 all over what? 4 plus I sine 0 times is 0 times is 0, I sine minus pi over 6 divided by 4. Okay? Now, what you'll be having finally is 2 bracket cos 2 bracket equals to 2 bracket cos, you now write minus pi over 6, change division to times. This 4 means 4 over 1. It will turn to 1 over what? 4. Plus I sine minus pi over 6. Change this division to times. 4 means 4 over 1. So invert it. 1 over 4. Okay? So you'll be having it to be 2 bracket cos minus pi over 6 times 4, 24, plus I sine what? Minus pi over 24. That is when you have it or when you want it to be in radian. Okay, most time the options are put in radian. Now remember that cos negative theta from trigonometry is equal to cos theta. That is for trigonometry. And sine negative theta is equal to minus sine theta. That is for trigonometry. And tan negative theta is equal to minus tan theta. So we have to recall it. So here, cos minus pi over 24 is something as writing is pi over 24. You have seen the rule behind we cleaning this minus because cos negative angle is something as cos of that angle. Then sine minus 24, sine minus pi over 24 simply means change here to what? Minus, and leave here to be what? Plus. Change here to minus and leave here to plus because sine minus theta is now minus sine plus theta. So this is the answer to the question that says express the principal argument of this in polar form. Thank you for watching this video.